Let's talk about one of the most frustrating universal experiences in modern life, the mystery of the slow computer. It's a problem that seems to defy all logic, right? But what if I told you it's not really a bug, but an intentional feature of the entire tech industry? Yeah, let's dive into that.
You absolutely know the feeling. You just dropped a ton of money on a brand new, top-of-the-line machine. You're convinced this thing is going to fly. But then, a few months, maybe even a few weeks later, you have a couple of browser tabs open, and suddenly the fan is screaming and everything just grinds to a halt. How is that even possible?
I mean, just look at this disconnect. A couple of decades ago, a PC with 2 cores and maybe 2 gigs of RAM felt perfectly snappy. Today, you could have a monster rig with 16 cores and 64 gigs of RAM, and yet the basic day-to-day experience often feels, well, about the same. Where is all that incredible power going?
And that, right there, is what we call the modern PC paradox. And while it's really tempting to just blame lazy developers for writing bloated, inefficient code, the real answer is so much more complex. And honestly, it has almost nothing to do with laziness.
The truth is, that slowdown you feel isn't some technical bug. It's the unavoidable outcome of a perfectly rational economic system. It really is a feature, not a flaw, of how the entire tech industry is built. So to understand why, we need to start by looking at this from a developer's perspective.
So let's step into the shoes of the people who are actually writing the code. They are facing this constant, intense pressure that shapes literally every single decision they make, and it leads directly to heavier and slower programs.
There's this famous observation in the tech world called Nathan's Law. The idea is super simple. Just like a gas will expand to fill whatever room it's in, software will naturally expand to consume all of the available hardware resources. So why on earth does this happen?
Okay, think of it like this. You move into a huge new apartment. At first, it feels amazing, right? So spacious. But with all that empty room, your incentive isn't to meticulously organize every little thing you own. It's to fill that space with new stuff. Well, in software, when memory and processing power are everywhere, the priority shifts from painstakingly optimizing code to just adding new features as fast as possible.
And this shift in priorities, it all comes down to cold, hard math. An expert developer's time is incredibly expensive. Writing super efficient code from scratch can take months. But using pre-built tools and frameworks, pretty much any developer can ship a feature-rich app in a week. For a business where time to market is everything, the choice is a no-brainer. Fast development wins over efficient code every single time.
And a perfect example of this is a popular framework called Electron, which is used by apps you probably use every day, like Discord and Slack. It lets developers build desktop apps using really simple web technologies. The catch? Well, to run a simple chat window, the app has to bundle and run the entire engine of the Google Chrome web browser in the background. It's like using a giant industrial crane to lift a tiny button. It is wildly inefficient, but it's so fast and cheap to develop.
Now, this developer's dilemma is just one gear in a much larger machine, what we call the great upgrade cycle that drives the entire tech industry.
You gotta love this old industry saying. It perfectly describes the relationship between hardware and software companies. The Andy here refers to Andy Grove, the former CEO of Intel, the chip maker. And Bill, well, of course, that's Bill Gates of Microsoft, the software giant.
So here's how this cycle works. First, hardware companies like Intel give us faster and faster processors, which creates this performance surplus, this headroom. Then, software companies like Microsoft come along and consume that surplus with new, more demanding features. All of a sudden, your computer feels slow again, which then pushes you to buy new hardware. And the cycle just keeps repeating, over and over.
Now, it's really easy to look at this and see a cynical conspiracy just to drain our wallets. But in reality, it's more of a symbiotic relationship. This perpetual cycle is actually what funds the research and development for the next generation of hardware and software. You could say this constant pressure is what drives innovation forward.
But hang on. Developers and corporations aren't the only ones to blame here. The final piece of this puzzle involves looking in the mirror, because we, the users, are actually active participants in making our own computers slower. This brings us to something called Wirth's Law, which was proposed all the way back in 1995. It basically observes that even though hardware speed is increasing exponentially, software bloat is actually outpacing it. The programs are getting heavier faster than the machines are getting quicker.
Here's a great way to think about it. Imagine the hardware is a racetrack,
and it's constantly being upgraded to allow for faster times. But the software, that's the runner on the track, is gaining weight even faster than the track is improving. What's the result? A slower overall performance every time.
So why does this happen? Well, just look at it from a marketing perspective. Speed is an invisible feature. It's really hard to advertise. But 10 new AI-powered features? Now that's a tangible, exciting bullet point that grabs your attention and justifies a new purchase. And come on, let's be totally honest with ourselves. Which one of those are we more likely to pay for? Our own consumer psychology rewards companies for adding more features, not for optimizing the ones they already have. We are literally feeding the very beast that slows us down.
So when you put all of these pieces together, the slow PC stops being a mystery at all. It actually becomes a logical, predictable, and frankly almost unbreakable system.
Think about it. You've got powerful hardware creating a vacuum. You've got the high cost of developers making it totally rational to fill that vacuum with inefficient but quickly made software. You have the entire industry's business model built on that cycle of upgrades. And then finally, you have us, the end users, consistently choosing flashy new features over invisible performance gains. So the crucial point, the main takeaway from all of this is this. Your computer feels slow not because the system is broken, but because it's working exactly as it was designed to. Software bloat isn't an accident. It's the economic engine of the entire tech industry.
And that leaves us with one final kind of provocative thought. It's really easy to wish for a world of perfectly optimized lightweight software that runs forever on old hardware. But if that cycle of bloat and upgrade is what funds all technological progress, what would we actually lose in a world without it?